So this one is a long problem, but there's a lot of different ways you can do part A. I'm going to do it probably the longest way so you can kind of see how the other parts relate. So if I start with 20 ounces of chocolate, each bite I'm going to take off 2.4. So 20 on my first bite, I'm just going to count them out. So 20 minus 2.4 gives me 17.6 ounces of chocolate left. All right, so he's going to take another bite. So 17.6 minus 2.4 is going to give me 15.2 ounces. I'm going to take another bite. 15.2 minus 2.4, which is 12.8. And then 12.8 minus 2.4 is 10.4. 10.4 minus 2.4 is 8 exactly. 8 minus 2.4 is 5.6. And so he's got 5.6 ounces of chocolate left, and he stops when there's less than 5. So he does have enough left to take another bite, but can he take another full bite? So not a full bite, but I'm going to say part of a bite, okay, to get down to 5. So let's count. So he's taken 1 bite, 2 bites, 3 bites, 4, 5, 6 bites, and a little bit more. So could he take 7 full bites? Nope. Now, there was a faster way to do that, but I kind of wanted to build the rest of the problem in. And if you're struggling writing your own inequalities, you can do this strategy. There's nothing wrong with it. So let's look at part B. If we start with our full candy bar, which is 20 ounces, can Brock take 6 bites of chocolate without needing to stop? Well, we just showed, yeah, he'll have 5.6 ounces of chocolate left. Now, if you didn't do that, what we could do is we can take 2.4 times 6, which is 14.4 ounces, and then I can take that off of the 20. This is if you didn't do the other strategy. So I know I have 5.6 ounces of chocolate left, and yes, he clearly can. All right, part C. Brock says that the expression 20 minus 2.4x helps him understand it. So he's able to set up an expression, which I think is great. So 20 is our total that we start with, a full candy bar, and 2.4 is how much he takes for each bite. So that's our chocolate for each bite. And then X, what does X stand for? Well, X stands for the number of bites that he's taking. When I took the 6 up in that problem, I did 2.4 times 6. So the number of bites. All right, not how much he took in each bite, but be very specific. It's the number of bites. All right, so part 6D. He says, write and solve an equation to determine the number of bites he can take without having to stop. So this is how much chocolate I'm eating. I've got 20 ounces, and then I take off 2.4 each time I take a bite. And I know I'm going to stop when there's less than 5 ounces left. So 5 is going to kind of be our like minimum where we stop. And so I want the amount of chocolate to be more than 5. I want 5 to be the smallest. Okay. So if I solve that, we want to get x alone. I've got to move the 20 and the 2.4. Remember, the 2.4 is by the x, so that's not alone. You always move the cheese that stands alone first. So I'm going to subtract 20 from each side. I'm left with negative 2.4x is greater than negative 15. The negative 2.4 and the x are being multiplied, so I want to divide by negative 2.4, divide by negative 2.4. Since I divided by a negative, my inequality reverses, and 15 divided by negative 2.4 is 6.25. So this would be our solution. So on part E, it says, explain clearly what the solution to the inequality means. So x was the number of bites, so that means that Brock can take less than 6.25 bites before he stops. And that's exactly what it means.